Okay, today we're going to look at section 5. They cut that out a couple of semesters ago. That's the section that deals with drawing graphs with those slant asymptotes. I'm not sure why they cut them out, but they did, so we'll abide by the rules. We're looking at inequalities from a different standpoint. First of all, I want you to remember, you can't put an inequality graph into your calculator. So don't try to go to a y is equal to and put a greater than or less than in it. Number one, let's just go back to what we already know. This is an inequality. I can subtract 2 from both sides and get a minus 12. And then I divide both sides by minus 14, and I get 12 over 14. But remember that when you divide by a negative number, you have to reverse the inequality. So this says the answer then is greater than or equal to, and we'll reduce it down to 6/7. Now, most of the time, they're going to ask for it in interval notation. So this says that the answer is 6/7, and it goes to positive infinity. If they ask you to put it on a number line, well, you can find us a 0 point. This is, let's call it 6/7, and then it goes to positive infinity. Okay. The kind that we're looking at today, though, is inequality from a different standpoint. Let's do minus 3x minus 4. Let's make it less than or equal to 0. Now, there are two ways to work these problems, and I'm going to show you both ways, and you're going to take your choice. So we're going to factor this thing. It factors into 4 and 1. The -3 says the negative go with the biggest number. This has to be positive. Is less than or equal to 0. So this says that x is 4, and this says that x is minus 1. Now, if you're going to do it this way, you simply put it on a number line. This is minus 1, and this is plus 4. So we got 3 intervals. I go to the right of 4. I go between minus 1 and 4, and then I go to the left of minus 1. This is a pretty good way to work these things. So let's just pick us a number to the right of 4. So if I let x be equal to 5. Okay. So the easiest place to plug it in is where you got it in its factored form. So that's going to be 5 minus 4 times 5 plus 1. And I'm really not worried about what the number is. I just need to know whether it's positive or negative. Well, this is positive times a positive. So it gives me positive. So anything bigger than 4 is going to make this thing positive. Now, let's pick any number between -1 and 4. Well, I'm going to pick the obvious. I'm going to let x be 0. So then I got 0 minus 4 times 0 plus 1. So I got a negative times a positive, which is negative. So anything between -1 and 4 makes this negative. Now, let's come to the left of -1. Well, let's use -2. So I got -2, -4, times -2 plus 1. So this is -6 times -1, and that comes out positive. Okay, so look at the original problem. He says, we want to know where this thing is negative. Well, it is negative for all values of x between -1 and 4. So the answer to this mess then is going to be on the interval from -1 to 4. Now, we used the brackets because it was less than or equal to 0. Okay. That is one way to work the problem. Now, I'm going to show you another way that's really, to me, the easier way, but that's left up to you. I'm going to simply draw a graph of the parabola y is equal to x squared minus 4x minus 1. And the reason I like this method is that you're still going to have to do this anyway. You got to factor this. So I get my two intercepts. I get -1 and I get 4. Now, if I'm going to do it this way, I'm going to treat this as an XY axis. Now, every parabola has a y-intercept. So if I let x be 0, y is -4. So I've got this point down here, 0, -4. I don't even care where the vertex is. I just know that it has an intercept here, and it does this. Now I want you to look at this. This is the graph of that parabola. Now, look at the parabola. Where are the y values negative? Well, they're negative between x is -1 and 4. And that's the same answer that we got right here. So as I said, there are two ways to work these. You take your choice. Preferably, I draw the graph and look and see. Well, let's do one more positive to see if we can let that make a little bit of sense. Okay. Now, same song and dance. We know we got a factor, so we're going to go ahead and factor. This is 8 and 1. Negative here says I had to have negative with the biggest number and the positive. So this says that x is 8 and x is -1. Now I'm going to go ahead and put it down on an XY axis. Okay. And this, if this was the parabola, when x is 0, y is -8. Now we've already got an x-intercept of 1, and we got an x-intercept of 8. So that means this parabola, and I want you to notice, I don't worry about where the vertex is. It's right over here somewhere, but it really doesn't make any difference with it. Now, look at my equation. My equation says, where is this thing positive? Well, aren't all of these y values positive, and aren't all of these y values positive? So the answer over here is that I start with 8 and I go to positive infinity. The answer over here is I start with -infinity and I go to -1. Now I want you to notice that I use the parentheses here and I use the parentheses here because it wasn't greater than or equal to 0. Okay, and this same thing applies, and that's the reason I like the graph method so well. Let's go back and we'll review something that we did a little bit earlier. Okay. Now, we're supposed to be able to draw this graph using what we learned earlier. But first of all, one of the x-intercepts is -7. So something's going to happen back here at -7. The next thing, something is going to happen over here at +2. Now, look at it from a graph standpoint. This has even multiplicity. So at that point, the thing bounces. This has odd multiplicity. So at that point, it goes through it. We only need one more point to get our sketch. And again, every polynomial function has a y-intercept. So I let x be 0. This is going to be 7 squared is 49 times -2 is -98. So we exaggerate a little bit. 0 minus 98. Now, that means that when this curve comes out of here, it has to go on through here. It can't bounce at that point. But it means that when it comes up here, it bounces at that point. Okay. Now, this is tricky. What's the answer to this mess? I want to know where this thing is less than or equal to 0. Well, aren't all of these y values around here negative? So I use x values from -7. In fact, I'm going to change my problem, folks, and I have a reason for that. I think one of your homework problems makes this little trick, and you need to be careful with it. So all of these y values right here are negative. So I'm going to have to use answers between x values between -7 and 2. All of these x values make this thing negative. Now, at -7, it was equal to 0. So to the left of -7, the thing still stays negative. So from -infinity to -7, and then I put that in union with -7 to 2. The union here says that, hey, I run up to -7, I don't use it, I don't use -7, and then I go on past it to 2. And I think you have one of those that do that, and that's the reason you have to break it down into these two sections. So I repeat, if you'll draw the graph and simply look at where the y values, in this case, we want to know where our y values are negative. Well, our y values are negative from here to here, and we had that little bobble that happened right here at -7. Okay. We don't forget what we've learned, and we learned to take out the common factor. So I take out an x squared, and that leaves me an x -4. Now, when I put this on a number line, I have something happen at 0, and then I have something happen at 4. This one we're into a little bit of hassle because it so happens that my y-intercept is 0. So I need to go ahead and pick me a number between 0 and 4 to see where I need to go from there. So I'm going to go ahead and pick 2. So if I pick 2, then this is 2 squared, which is 4. 2 minus 4, which is -2. 4 and 2 is -8. So I'm not saying that's a turning point. I just know that when x is 2, y is -8. That's the only point I need to draw this graph, because this is even multiplicity. So when it gets to 0, it has to bounce. This is odd multiplicity. So at 4, it has to go through it. So the graph has to go through at 4, and it has to bounce here. Now, look at my problem. My problem says, where is this mess positive? Well, the only place it's positive is right up here. All of these y values are positive. So the answer to this mess then is going to be, I start at 4 and I go to positive infinity. I want you to notice that I don't include 4, because 4 would make it equal to 0, and we wanted it greater than or equal to 0. Okay. Now we kick it up just a little bit different style. In reality, these are easier, and I back off of my graphing method for this one because it's easier just to put it on a number line. Okay, number 1, I got critical points. Something is going to happen at -3 because that makes this 0. So at -3, something is going to happen. And also at +5, something is going to happen because that makes this 0. Now we're going to go in a different interval. So I'm going to go to the right of 5. Let's pick 6. So it gives me 6 plus 3 divided by 6 minus 5, which is 9 divided by 1. And that's positive. I don't care that it's positive 9. It's simply positive. Now, pick me any number between -3 and 5. Well, I'm going to pick the obvious. I'm going to let x be 0. So this is going to give me 3 divided by -5. So when x is 0, I end up with a negative 3/5. The important thing is that when I go between negative 3 and 5, it comes out negative. Now, let's pick a point to the left of negative 3. Let's pick negative 4. So I got negative 4 plus 3 over negative 4, negative 5. I get negative 1 divided by negative 9. And the important thing is that that comes out positive. Now I want you to look at this mess thing. It's positive to the right of 5, and it's positive to the left of 3. Our problem says, where is it negative? Well, it's negative between negative 3 and 5. So the answer to this is going to be everything between negative 3 and 5. Now, I want you to notice that I didn't put brackets at either place, because negative 3 would have made the numerator equal to 0, and that would make it equal to 0. We don't want it equal to 0. We want it less than 0. We know we can't use 5 because 5 would have made the denominator 0. Okay, one other kind. Let's get back to it now. I want you to notice this one is different. It is less than 1. So we got to go, really got to go back to a 4th grade concept, folks, because we want to compare this mess to 0. So I'm going to bring this 1 over here to this side. And that leaves me nothing but 0 over here. Now, in the 4th grade, I got a fraction and a whole number. I got to get a common denominator to get my fraction. So my common denominator is going to be x minus 15. All right. Now, so we know that our denominator is x minus 15. Now do the algebra in the numerator. It gives me minus x and plus 15. Now, minus x plus x cancels out. So I got 31 divided by x minus 15 is less than or equal to 0. Now, put this on your number line, and something's going to happen over here at 15. Okay, so we go to the right of 15. Let's let x be 16. So that's going to give me 31 divided by 1. The important thing is that it's positive. Now, go to the left of 15. You can use anything you want. I'm going to let x be 0. So that's going to be 31 divided by minus 15. So that means that it's negative. So look at your equation. Your equation says, where is this thing negative? Well, it is negative to the left of 15. So the answer to this problem is going to be from negative infinity up to 15. Now, I want you to notice that I didn't put the 15 in the brackets, because if I use 15 here, my denominator would be 0, and we can't have that. So this is the answer to the problem, everything to the left of 15. All right, that should do it. I want you to notice that this is section 5.4. That means we've covered 5.1, 5.2, 5.2, and 5.4, which means that you're also got a quiz scheduled for Monday night that will be on those 3 sections. Tuesday we'll go in and we'll cover one more section. Good luck.